All right. Thank you so much for having me. Fun fact: I was here like I think it was 2 months or 1.5 months ago, where was the localhost conference was my very first conference talk. So I'm excited to be back for a second time so soon. But it also faced me with an issue because I didn't want to do the same talk over again, and because I knew some faces here and are familiar to me, so I didn't want to repeat the same talk. So I've adapted it a bit. The first talk was about I'm part of the Preact team, and it was about how can we optimize code. And this one is more not how did we optimize Preact, but how can you optimize your code. So it's a bit with a different focus. A little bit about me. I'm Marvin Hagemeister. Fun fact: my name is typical German, so it's very long, and it's a good way to test layouts. And it's also really great. Like Twitter has a limit on characters you can use as your handle, so the last ones didn't make it in. So my name is cut off. But it's also when you have conference websites and you use them on the mobile browsers, usually my name pushes out the layout to the right, so you have like a blank space there. But it's a fun story. To me, I'm a software developer, mainly active in web for about 8 years now. I'm a consultant at Awesome Software. That's the real name. And we do basically consulting for enterprise markets like banks, insurance companies, or any other bigger ones. And you see a lot of legacy code, to be frank. So for me, it was a good thing. I needed something else to balance it out, and so I joined the Preact team about I think 2 years ago now. And Preact, we'll talk about it later, but rest assured, I'm really obsessed with simplicity and kind of taking complex ideas or complex code and reducing it to the bare minimum or to the purest essence of that idea, which is not easy, but it's a fun challenge. It's like a puzzle. So Preact, yeah, it's one of the slides I had to reuse. So what's special about it is that it's only 3 kilobytes. It has always been 3 kilobytes, in fact. So if you watch there's a site called Bundlephobia where you can check the import cost of a module, and Preact has always hovered around 3 kilobytes. It has never been more. So, which is kind of cool, and many people don't believe us, but we in fact have nearly full compatibility with React API. So much, in fact, that many people just drop it in via a compatibility layer and have their app work. I wouldn't say it's 100%. I would say it's like 90%. So we are lacking. We don't have concurrent mode, which I don't think many apps need, to be honest. And we do have an experimental version of Suspense. It's not yet ready yet. So this is the things you're basically leaving behind when you switch to Preact. But nonetheless, it has some famous users, like Google is using it for Google AMP. Smashing Magazine is built on it. Dev.to is built on it. I think bodybuilding.com is also, and we have like a bunch of other sites which are really popular. The thing with being a framework is that many people don't tell you when they're using it, so we poke around sites. So we found our code in Disney Plus, which is kind of fun. But they're using a pretty old version of our framework, so we're not sure what's up with that, but that's legacy software. So this is the full source code. This is everything. You can print it on your T-shirt. It's run through Cursor, so we do not code like that. It's the output of the compiler. No worries. But I think it's kind of cool to see that it fits on a DIN4 page, which is like quite the accomplishment. And you also recognize, maybe if you squint hard enough, there are long names like should component update and whatever. Like here's component will unmount, and so these are the names, the lifecycle hooks. So if the API names would be shorter, we could cut a lot of it. So yeah, but it's you can't get people behind board like using single letters for function calls. Like nobody wants to do that. With that said, I was wondering, okay, what can you take away from this talk for your code? Like, do more with less, which has always been our motto, and we always we have this battle between reducing code and adding features. And often, when we add features, we have to take away something first. Otherwise, we'd blow past our size budget. So there's always a trade-off and always a balance. So the funny thing is, when you're a consultant and you go into different companies, everybody has a different definition of what simple code is. one person says, okay, it's my pattern, I'm coming from the Java world, or the other person says, I'm from, I don't know, Haskell, only this is the right way. So everybody has a different opinion of what simple code is. And so maybe is simple code short? To be honest, I don't know. I don't think it is. If you look at our code, this is the function that compares an element to another. It's about 150 or maybe close to 200 lines. But it never feels like it's hard to maintain or it's difficult to work with because it's so clear structured. And so, there's always this saying, some devs come to you, like when you consult it, functions should never be longer than 20 lines, or they should never be longer than 30 lines, or whatever. So this is probably an artifact from older times when screen space was limited, or you couldn't fit as many characters into memory. So back then, or at least I'm told, like my father told me that programmers were paid by the line. So the more lines you wrote, the more money you got, and maybe that's how Java came to be. But we don't know, sir. I wasn't around at that time, so I can only guess and make assumptions. So if you take this function apart, like the first few blocks are the arguments, and Prettier formats it as a separate line for each argument. The first part deals with component construction. Whenever we encounter a new component, we need to create an instance of it. And after that, we have the lifecycle things. This is for the class API. This is not for hooks. And the class API is a bit tricky to get right because you have to be very careful when you call a certain function with the right arguments in the right instance and reference of props, or otherwise everything will be messed up for some weird third-party code. So we have to be very careful, and this takes the lion's share of that function. If we can get rid of the class API, we can drop a lot of code. So this is a little thing that renders the component, which is nothing in comparison because we just call a function and get the result. And then we have a little bit of code that deals with children. In fact, this piece calls out into another portion of our code base, which is not represented here, which does reconciliation, like check has the ordering of the elements changed, has the first element moved to the middle, or was one deleted of those. So this is also a big function, but it's nonetheless, it's shorter than this one. So, and after that we have some, like we apply the changes to the DOM, and we have an if branch because components don't create DOM nodes directly. They return child nodes, which in turn create DOM elements. So we have a little bit of code that deals with that. And this again calls out into another function. So it's not like we have one big function and this is Preact. We do split out code into different functions, but we only split them out when it makes sense to do so. Like if you have just like one call side, or it's questionable. We always question, what do we gain from extracting this code? Because once you extract too many things, you have to jump around files, and you often end up like, I think it was 2 days ago, I was working on a project for a client, and one of the devs basically has abstracted the map object in JavaScript. So you have like add element, and he just calls map.add, or map set is the name. So it's just a single line, and every function was a single line. And once you move everything together, you could just use the map API, and there was no benefit to abstracting over native objects, which is I think an issue many younger devs fall into. So simple code is definitely not short. It often is shorter. Like if you cut down useless abstractions, it obviously gets shorter. But I don't think simple code has to be short. Like it has to be easy to understand and easy to maintain. So short isn't it. So what is it? I was wondering if I could find a good definition for simplicity, but maybe it's better to define the inverse of simplicity, which is complexity. And I found this quote in a book, and I think he's right on point that complexity is when something is hard to understand and modify. You always know if you're dropping into legacy code base and you think, okay, I need to add this feature, it will probably take me around like 1 or 2 hours or maybe half a day. And you look at the code, and in fact, you have to touch so many points in the code base, or maybe you have to invent new things, that the simple task is now a monumental task and takes about a week or maybe even more. So I say this is complexity, and I would say simplicity is the inverse of that. And one enemy of that is, of course, cognitive load, because we have to, what is complexity? And if you think about it, it's when you have to keep different parts of the system in mind. You cannot reason with locality about the current area where you're working. You have to keep several different areas in mind before you can touch your code. And it also leads to a lot of bugs. This is a simplified example, but I don't know who does spot the bug. There are 2 bugs here. Okay, I see a few hands. 1 hand. Yeah, so I'm not sure. Like question marks. The issue is if you do not call the init method, the methods below will fail because items is null. And you're calling push directly or pop directly, although these are methods reserved for arrays. And this is a pattern I encounter a lot in code bases, especially when it comes to component classes. One fact is, this is an example from typical React components, which are written in these classes. You have the ref attribute on a DOM node. You can use it to get a reference to the underlying DOM element. And this will be set after the first render. There was a previous version before the create ref API where you'd use a class member, and this function would just assign it to the member. In this case, this .ref. And if you look at the component mount method, it always expects this variable to be there. But if we look closer at the render method, it's not always there. And this is an issue because if you look closer here, we have a condition here. Like the div element is only rendered in certain cases. So this in turn will lead to this .ref being undefined and not present. So you have a bug in this code. And this is not an example that is made up. I've encountered it frequently in a lot of code bases which are written in classes. So for us framework authors, it's very important to have APIs that guide the user to do the right thing, which is very tough and a very high bar to meet. And we're always iterating on that with other frameworks. So another thing that leads to complexity, maybe not in this example, is when you delegate too much, when you have a function call that returns something else, and in effect it just wraps that. Sometimes it's useful if you have more composable strategy, but oftentimes this pattern is done like 7 layers deep and nobody knows which props belong to which one. So you have this giant component with like 50 props or something. And at that point, you basically should really rethink if you have cut the components right. Maybe you should extract more, be more component storybook-like or anything. This is usually a good idea to check. And of course, risky assumptions. This is a fun fact because, as you know, nobody reads docs or only in rare instances. So devs assume a lot about your framework, a lot about your code, and a lot about your friend's code or whatever. So one example, this was I think a month back. A new dev, he was, I think he's like two years in his job, and he was using promises here, like we can see in the first example up there. He's using some API call, does something with a result, and then calls a callback, and think like, wait a second. Why didn't he continue to use promises? Why did he opt back to callbacks? And when you see the invocation of that code, it's down here. You're just using the callback API, and you think, well, we have this thing called promises. Why is he not using it? And it turned out he never looked promises up. He always learned it from the way of grabbing through the existing code base. And he wasn't aware that you could chain .then calls. He always thought that you can only do one .then on a promise, and that's it. Which is a weird assumption to make, but for me it was like, I realized, okay, that the next generation of developers is used to computer telling you what's wrong or what you can do better. And maybe we're not doing a good enough job of that. They do not seek out and actively discover things on their own as much as people used to. So, which is interesting because once I showed him his error, I don't have the slide here, unfortunately, or maybe I messed the order up. Like he was kind of surprised how much easier his code got once he got rid of all the callback hells that he has gotten himself into. But this is just something where he made an assumption, and which is very, very like you have as a framework author, you have to kind of guess. It's like back in school where you have to guess the teacher's correct answer in his head to ace the test. So it's kind of like that. One other thing that leads to complexity is weird APIs. This is also based on assumptions. Who knows what this function returns when when the required attribute is present on the DOM node? What do you have here? Required, right? A Boolean string. It's a Boolean attribute.
It's always a string.
String. Yeah. Yeah, it's the older APIs did return required, and the new ones, the get attribute variable returns the string false or the string true, and it has a third value null when the attribute is not present. So in fact, a Boolean has 3 values, which is weird if you think about like why has a Boolean 3 values? But this is a case where legacy software took over. It's because of XML, and the early drafts of HTML were really, really XML focused. So they thought it would be a good idea to have this information into JavaScript, but it doesn't make any sense because there's just a Boolean, like it's either true or false. There's no difference if it's not existent. It makes no sense. So, okay, that's just it. So another thing that is really difficult or that leads to complex code is dependencies and obscurity. I touched a bit about a little earlier when you have to make one change in a piece and this trickles through all your system, and I just want to change this thing, but I need to change that over there and that and that and that. So you have like a whole round trip going through the whole code base, which is sometimes adventurous and sometimes a little bit of fun, but this leads to hard to make changes. And in our case, the reason Preact is only 3 kilobytes is not, like we love doing it, no doubt, but it's also because we don't have that much time. Like everybody, like for me, I worked for it for a long time, only on my commute to work. So I had like half an hour in and half an hour out. And to be able to effectively contribute, you need to have a good understanding of the code base and be able to just drop in, make a change, drop out. And if there are more barriers in this process, the contribution gets really hard. So we wanted to make it as easy as possible for us to make changes and to make big changes. So this is very, very cool when you have like a small code base. You can do a lot with it. So in essence, I would say my definition of code is simple code is boring. There are no smart tricks there. There are no weird shenanigans. Simple code is kind of the obvious code that you would write. And sometimes you have like complex situations and you're looking at the solution afterwards and everybody thinks, oh my God, everybody could have gotten into this. And this is the good code, because if the solution is obvious, it may take a few tries. You'll never get it right in the first try usually, but the obvious code is the simple code, and that's the one that's easy to maintain. So it takes an effort. It's not easy, definitely not. Like writing complex code is easy, but simple code is hard. So this is another slide I had to reuse mainly because I got a lot of tweets out of it. Simplicity is not familiarity. Many people confuse the two, especially in legacy software, saying, I've been doing this process for 20 years, like clicking this button, clicking that button, changing the knob here. It's easy for me, so it's easy for everybody else, right? But the thing is, it's not true for a newcomer. It's like a mind-bogglingly huge number of steps he has to do to achieve a simple task. So just because it is familiar to the person who has been longer there doesn't mean that it's in fact easy. So this is also an issue that we always have to be conscious about, because we know our own code a lot. So we always think our own code is the best. Our own code is the easiest. But the best way to test that is similar to your usability testing. Is the best way to test your code is to put it in front of people who have never read your code. Because this gives you a good indicator, like how well do they understand the relationships, how well do they understand what you're writing there. So I think this is very important, especially when it comes to legacy software, because they're running for more than 3 years usually, and the people that were there from the start, they know every ins and outs of the code base. But if you really look into it, there's a huge cost associated for onboarding newcomers. So the main function I showed earlier was this one here, where we compared an old element to a new element. We call it the process diffing or comparison. So I wanted to show you a way how we can do stuff easier, like more deep dive into code. The first slides were a bit more high level. So maybe you've seen this code or similar code, like you have a div element and you want to render 2 divs into it. And in this case, you iterate over an array. So you have like div1, div2. And there's a special case hidden there because in the end you have an array here. And if you have more elements before or after, you have like element type array, or anything. So you have like a mixed type. And our first solution to this problem involved extending our function that we could deal with an argument being an array. So this led to an explosion in variants, like the first one where we're just comparing straight to vnodes, and then we had like, what if the first type is an array and the second type is a vnode, and vice versa. So you have like a lot of combinations that you need to test. This is how it looks like. It's not pretty and it's really uncool. So being so size constrained, we looked at ideas, how can we simplify it? And luckily, Andre from Microsoft, he's in our team, he's a really cool guy. He's really the discipline guy. We can just power through things. And he came up with the idea of what if we only go back to the case as before, only comparing straight up vnodes, by simply, okay, this is shit, maybe a good smiley, mainly by changing some things. Like what if we swapped out the array for a component? And then we always have, that way we have defined all special cases away. With this change, we could reduce a lot in our code base. It got a lot shorter, and the fragment implementation it costs us nearly nothing, because we just have 1 or 2 lines which just say, okay, here's an array. We check if the return value is an array, and if it is, we just wrap it with the fragment. Done. It's the only piece of code we had to do to add support for returning arrays. And this is also, I think, if you step back a little bit and really think about the data structures that are moving through your systems, you can really can simplify the effects a lot of your own code, and also the API surface of the consumer. So this was one case. In the new version looks like this because we have no special cases anymore. Our code got shorter. And it's a good feeling to have. Like, I always try to come out of a project when I'm consulting with a negative commit count, and so far I've achieved that. And one other thing simple code bases lead to is lots of experiments. Like, we're doing a shit ton of experiments. When hooks came out back then, like even before Dan got on stage and announced them, we had some information about what was coming up on stage. So Jason Miller, one of the core developers, just put out a simple gist that showed how hooks can be used in Preact, like right alongside. And by the time Dan was done with his presentation, we had a simple prototype ready, which is kind of cool. It took us a while to iron out all edge cases, so we didn't release it right away. But it's cool to see that you can easily go in and change the core assumptions in your code bases. So this is it. This is like a simple, he just focused on the useState hook. So this is the function which basically initializes the hook states, and then we have like a simple useState hook, and he had like one special render function to make it easy for him to test. So yeah, it's kind of ridiculous how few lines of code that is, but it works. And it even worked with the older version of Preact, which is kind of hilarious. But Jason is always the guy who can just bang out gists like nobody. It's insane, that dude. Yeah, complexity, like how can you make sure, for us a long goal is not just to be, okay, we are 3 kilobyte at one point in our lifetime. We have to be consistent. We have to be consistently at that limit. So I think the mistake many projects make is like, okay, now we do the stop the world refactor. Now we make everything great again. And after this is done, the expectation from management is, okay, now we do not need to refactor for the next, I don't know, 3 or 4 years. And I think this is a very, very dangerous assumption to make, because I see code is more like gardening. You have to care for your flowers and you have to let them grow and experience and try out new things. So I'd say like refactoring is a constant neighbor or a constant guest in your code base. So you have to, for me personally, I try to allocate about 20% of my time I have during a sprint for refactorings. I'm not sure what that is when I'm starting the sprint, but you'll find enough if you just peek around in a code base. There's always something that could be done better. So this is one example that we did in Preact, where we just like the previous version of Preact compared like incremental DOM, by the way, where Melody is based on, it diffed a virtual tree right against the DOM. So there was no second virtual structure. And because you're comparing two different data structures with different attributes, different properties, and maybe even different ways to access those, you had a lot of code to catch edge cases. In this case, the most edge cases here came from us comparing strings to text elements compared to standard DOM elements. So with Preact X, we again normalized our data structures. We compared two of the same trees with each other so that we could drop a lot of code again, similar to the slide before. And this is a huge chunk, and you can do it with, like, you get the impression that we could say a death to all if statements, and I would sign that, because we do believe that every if statement is an opportunity to add more complexity, and in turn can effectively double the test count or the checks you have to do to ensure that your code is right. So in summary, this is the last slide. I would say, like, write boring code, please do. It's the most joyous thing to do. Think about the common case your API is to be used. There's no point in moving the complexity to the user and telling him, hey, you need to do this option, that option, and this option before this thing works the way you expect it to. So it's kind of plays back to the assumption thing. And allocate enough time for refactorings. Very important if you want your projects to remain healthy throughout their lifetime. And of course, iterate all the time, iterate everything. And because the first solution is maybe a good way, but it's never the right one. And in our case, like, we love experimentation. And I think allowing us to experiment the way we do is the single thing that has allowed us to stay relevant in this day and age, because we do not have that much time to spend on Preact. With that said, thank you so much. This is my last slide. We're also an open collective, so I'm excited about the talk later. We have nobody working on it full time, but we'd love to. So, but we need more sponsors. It's an open call. So yeah, hope you enjoyed the talk. Thank you so much. Have we a little bit of time for questions, or? Right, awesome. So any questions here, like about anything? Take the cube.
So you went from Preact 8 to Preact X.
Yeah.
Is that like because of the iPhone thing? And
Yeah.
is the next version then XR?
Yeah, we did it the Apple way. The reason for that is we always planned to do a version 9, but we always planned it to be, I should backpedal a bit. When we started working on a new version for Preact, we weren't sure what it would look like. So we started experiments and lots of it. And over time, one experiment got a lot of attention, and we always think it's just an experiment. It will never be the next version of Preact. And at one point, we had to say, okay, this will be the next version of Preact because that experiment was so good. But the thing is, we weren't sure because we aligned a lot of, I would say, internal property names with the React team to make collaboration easier and to make it easier to reuse third-party components. And we wanted to do a release in between to ease migration. Like, we wanted to release a version 9 which would just have the internal breaking changes but no new features. And once we announced version 10 and published the first alpha, everybody was jumping on it and had like no issues. Like, okay, of course, there's a few issues here and there being an alpha software, but there weren't much issues that prevented React users from adopting our code or previous version of Preact and upgrading it to version 10. So we are a small team, so we made the decision to skip version 9. Which looks weird, I get that, but so does Apple, so I guess it's okay. Any other questions, like about anything? Right, not mine.
I would be interested. What's the relationship between the React team and the Preact team? Do they view you as competitors or as a nuisance or as a challenge or anything in between?
Yeah, that's a good question. And I think the way I see other frameworks in general, in particular the React team, is that we're all trying to solve the same problem. We're all trying to solve the problem, how can you make web apps easier to build? And there are different perspectives or nuances to that idea. Some approach it more from the compiler side, like Svelte or Angular. Others, like React and Vue, and even to some extent Vue, approach it from a runtime perspective. And I think there was a little bit of competitiveness early on, and it still is, but more on a friendly level. This has changed when Jason, the creator of Preact, joined Google, because then he has some projects where he worked directly with the React team, and it took some while to get friendly, but now we're sharing ideas, and I'm in close touch with many of the React team, and we have sometimes hangout calls or anything. It's more like the React team mainly builds React for Facebook.com and Instagram, which is like you have to satisfy a framework for God knows how many developers, and they have like, I don't know what the exact number is, but they have like more than 25,000 components, and they cannot upgrade everything. The way it works at Facebook is that whenever they make a breaking change in React, they are the ones who have to upgrade the components, not the relevant teams who wrote it. So they cannot make breaking changes as easily as we do. And us being more constrained on size, and I would argue, but I'm biased, for more of the common web apps that people write today outside of Facebook, we can make more drastic changes. But nonetheless, we kind of do enjoy each other's ideas, because sometimes we gave an idea to them, sometimes they give an idea to us. It's more friendly.
Thank you.
Yeah. All right, I think that's it. I'll be hanging around here later for open source. There are some stickers if you want some. I even have more. And yeah, thank you so much for having me.